In this video, let us look at the general features of a titration curve. A titration curve looks something like this, and it shows the change in pH as the titrant is being added to the conical flask. The solution in the burette is also known as your titrant, and the solution in the conical flask is known as your analyte. Throughout an acid-base titration, there will be variations in the pH value that correspond to the different stages of the neutralization process. In this case, let us consider the example of the reaction between hydrochloric acid and dilute sodium hydroxide. For this experiment, we will be titrating hydrochloric acid, which is in the conical flask, against sodium hydroxide, which is in the burette. So if we have a scenario whereby we do not know what the concentration here is, we can find out what the concentration of hydrochloric acid is by considering how much of sodium hydroxide we have to add for neutralization, and then we can do the back calculation. If we were to graphically plot the pH changes for the neutralization of HCl by NaOH, you will get a graph looking something like that. Let us see what information we can get from the graph. Initially, there is no sodium hydroxide being added, so all we have in the flask is hydrochloric acid. And since we know that hydrochloric acid is a strong acid that fully dissociates in water, the pH is low. As sodium hydroxide is being added from the burette, neutralization and dilution leads to a decrease in hydrogen ion concentration. This is because the hydrogen ions here are being neutralized by sodium hydroxide, therefore leading to the decrease here. And because of this, there will be an increase in the pH. A large rapid change in pH, in this case from about 4 to 10, indicates the approach of the equivalence point. At the equivalence point, the acid is completely neutralized by the sodium hydroxide. And reading from the graph, we know that 25 cm³ of sodium hydroxide is required for the neutralization. At the equivalence point, we only have salt and water, and we know that the pH will be neutral. If we were to continue adding sodium hydroxide, the pH will continue to shoot up and rise to a value typical of a strong base that fully dissociates in water. Now let us take a look at the different species that are present at different points of the neutralization process. Initially, we only have hydrochloric acid, and as we add sodium hydroxide for the neutralization, we have a mixture of the unneutralized HCl and the products of neutralization. Over at the equivalence point, there is complete neutralization, therefore there is only salt and water present. Beyond the equivalence point, there is a lot of sodium hydroxide present, but also the products of neutralization are still there.